So in this video we are going to take the scratch work that we previously completed and use that to complete the proof for the limit as x tends to 2 of 5x plus 1 equals 1. So I've already got the first sentence started. Typically what you want to do in these proofs is indicate that you're writing a proof, so I've written proof with a colon. And now the first sentence I've got is, let epsilon greater than 0 be arbitrary and let delta equal epsilon over 5. So remember that we want epsilon and delta to both be positive, and remember that epsilon can be arbitrary. In fact, it is not stated, it's not chosen at all. It is arbitrary, and so that's what we're starting. That's what we're doing right here. This epsilon could be any epsilon we're given, and then you remember that the delta we found previously was epsilon over 5. All right, so let's continue with this proof. I've got our scratch work from before. All right, so remember that what we want to do is we want to start with this statement and end up with this statement. And so we're going to just work our way backwards through this scratch work that we've done before. So we would start out with something like this. Let x be such that the absolute value of x minus 2 is less than delta but greater than 0. I nearly forgot that part. Another thing I need to mention is that you should write your proofs in complete sentences. Alright. Now you remember the next thing we did was remember that delta is epsilon over 5, so let's rewrite this expression with delta replaced with epsilon over 5, and I'm just going to write it this way. Since I want to write in full sentences, I'm going to say it follows that the absolute value of x minus 2 is less than epsilon over 5, just by a substitution. Now, you'll notice I left off the 0 is less than part. That's because while that is necessary to keep x from going all the way to 2, it's not necessary for the algebra that we're doing. Alright, so let's continue. We next need to go from here to here, so we might say something like multiplying by 5, and if you want to, you might say something like multiplying each side of the above expression by 5, we get 5 times the absolute value of x minus 2 is less than epsilon. Now what do I need to do? Well, I need to get that 5 inside here, and I need to multiply. I need to get the 5 inside the absolute values. I need to distribute that 5 across the x minus 2. So I think I'm going to combine all that into a single step with the following. Distributing the 5 gives us the absolute value of 5x minus 10 is less than epsilon. which can be rewritten as, and so we've gotten to this stage right here, and so I just need to go up here to this, and so I'll just write that as the absolute value of the expression 5x plus 1 in parentheses minus 11 is less than epsilon. And we're done. And I'm going to indicate that we're done by drawing a square. Another thing you could do is use these sort of 3 slashes. Sometimes people write QED. Now, if you wanted to be even more clear, I suppose is the way to say that, you could say, we have thus shown that the limit of 5x plus 1 as x tends to 2 is equal to 1. But I think this is sufficient for what I'm looking for. What we've shown is if we start out with x being close enough to 2, how close? Well, within epsilon over 5, that f of x is as close to 11 as is demanded. All right, that concludes our proof.